This text analytics course is about getting meaning out of written documents in cases where we have far too many written documents to read them each individually. So the basic question is, how can we understand the vast amounts of human knowledge that are being stored as text data? And this is an increasingly important problem because we have so many things that we couldn't ever possibly read them all. I want to give two examples here. First, looking at political discourse in the form of speeches in the United States over a 140-year period from 1873 to 2015. And second, looking at digital text and how we can use this to map both languages and also populations. So starting with political speeches, here we're looking at the number of words per Congress over this 140-year period. And overall, it's 1.18 billion words of speeches. And this is, again, far too many for us to read and understand each individually without devoting a lifetime to the study of this. And of course, one of the problems is that if you read each speech individually, by the time you get to the end, you're not going to remember the nuances of every particular part. So the question is, can we understand the behaviors given the text data that we have? And by behaviors, I mean people's political actions. So here we're looking at a voting-based measure of behavior. And so the higher that this measure is, the more partisan a particular Congress is. In other words, the more people are disagreeing, as evidenced by the way that they're voting. And this is providing a ground truth because we have recorded votes for this entire period. And so we can see variations in how much people are agreeing or disagreeing with one another, variations in partisanship. But the situation is that we have people who belong to these two political parties. Each of them is producing speeches, producing language data. And instead of relying on this roll call voting behavior, what we want to do is use text analytics. And so in this case, we're going to use a text classifier to make predictions for each Congress for individual speeches about what party the person who gave that speech is representing. And here we're looking at normalized classification accuracies over this 140 period. And we see a lot of fluctuations in how good the accuracy is. Now the accuracy means that we can predict that this speech was given by a Republican, this speech was given by a Democrat. And the point is, what does it mean when it's easier or harder to make that classification? And so here we're looking at the correlation between that voting behavior and how well our classifier works over this entire period. And there's actually a very significant correlation between these two measures. Now the point here in terms of text classification is that we could have this one ground truth measure of voting behavior, or we could get at that same information by using text analytics methods applied to the speeches themselves. And of course, the text analytics methods can be scaled. They can be looked at, used to look at many different data sets, and that's what's exciting about them. And the second example I want to talk about is understanding human populations using language data. So in this case, we're going to take 8 billion word Twitter corpus and 400 billion word web corpus and use it to map where particular languages are being used. So the first thing that we need to do is understand variations in the population. So here we're looking at a ground truth map of population. The darker a country is, like Asia and China, the more people live there. And here we're looking at a density map for our Twitter corpus. So the darker a country is, like the United States and Canada, the more of the Twitter corpus is coming from that place. And so we see a disconnect between these two entities, that some people have more access to digital communication. Now, a really driving factor of this is the percentage of the population in a particular country that has access to the internet. So here we're looking at UN estimates of internet access, and we have places like Australia, New Zealand, Western Europe, United States, and Canada where most people can use the internet. But then we have other places like India and a lot of Africa where people simply don't have access. But what this means is we can model these differences and make projections. So here we're looking at what the web corpus would look like if everyone had internet access. But the point is, we can take that data that we have, the Twitter data, the internet data, and correlate it with underlying population densities that we know about, and project it into a space as if everyone were equally represented. And then we can look at language mapping. So here we're looking at countries by the percentage of language use for each country, which is English. And so the first thing we see is that English is used all over the world. So even countries like in Africa and South Asia, that prototypically aren't thought of as being English-using countries, are producing a lot of English data. And the other thing that is interesting here is that English is used often as a second language or another language. But this is telling us information about language use, in this case for English, using text analytics methods. Now this becomes interesting as we look at other languages. So we have Spanish, which is an international language in South America, Central America, and Spain, but we don't see it being used as a second or other language in the same way. So a very different profile. Arabic is interesting because we have this sort of central prototypical Arabic-speaking population, but as that population moves around the world because of migration and other factors, the Arabic language moves with that population. On the other hand, we have languages like Hindi, and this is true on both data sets, where it's really concentrated in this geographic area of countries adjacent to India. And as that population moves because of migration and other factors, the language doesn't seem to be continuing to use in their new locations. And so what we see is two very different kinds of behaviors in terms of whether people are using their language in other places or not using their language in other places. But text analytics is what lets us understand these patterns in the aggregate, because it would be impossible to look at this in a manual way, right? So we need to figure out how to analyze text data sets in the aggregate in order to get this kind of information. And that's exactly what the text analytics class is about, and it's coming semester 1, 2020.